Welcome to the webinar. So I'm a technical consulting engineer for Intel Performance Libraries. So basically, in this session, I will give you a presentation regarding how we can use Intel Performance Libraries in the IoT applications. So thanks for joining the sessions. So yeah, let me share my desktop. So okay, today my focus will be focused on the Intel Performance Libraries on the IoT application. So basically, Intel provide many different performance libraries that can help us to develop IoT applications, including some like image processing libraries that can help to process image, some signal processing libraries for processing some signal data, and some mathematical functions that will be focused on the mathematical computations, or even be focused on the neural networks, on the matrix of computations, and other applications. And for some classical machine learning, Intel also provide a library called Global Library. So that is that can help on some classical machine learning problems. And if we have some threading related questions, problems, Intel also provide a library called Intel threading building blocks. So basically, that can help us to handle with some threaded related problems. So basically, for Intel side, we provide a bunch of applications that can help us to process our libraries. So basically, this library can help us to handle different of the IoT related problems. Before we started, so what we are going to look at a suite of tools that Intel provide for embedded applications. Intel offered Intel System Studios. This tool suite includes some compilers, some libraries, and even some analyze tools that can help us to process, to help us to analyze the performance issues, and also we have a debug tools that can help us to to debug some low-level debug problems. So basically, this is a suite of the tools that can help us to developing the embedded applications. So that is a suite of the application that can help us to handling a different of the embedded applications. Today, I will just very focused on some libraries. So basically, this is a suite of the embedded libraries. So that can help us to handle in different problems. So and this is another picture I'm going to show you on Intel Performance libraries. So basically, we have Intel IPP. So this is a library is very focused on some image processing and the signal processing and even some computer vision applications. Also, we have a few of the mathematical functions. So that is very focused on some mathematical computations. And so if you have any mathematical computation problems, for example, you want to solve some matrix computations, if you have some linear solvers, so basically MQL offered some mathematical computation functions and can help you to on this problem. Even in the latest version of the MQL libraries, it also included some functions on neural networks. Basically, if you have some machine learning code, if you want to do some deep learning, MQL can also provide some DNN primitives that can help you do some machine learning related works. And in beside these two libraries, we also have a DL, Intel DL libraries. So that library is problems like some linear regressions, like some PCA problems. So basically, so DL can provide some functions to help you on this part. And also from the threading part, so Intel also provide a threading library called Intel Threading Building Blocks. So basically, so that libraries can help to handling many many threading related issues. If you have some threading related issues, so you can take advantage with threading building blocks. So all these are some 4 basic libraries that can help us to facing some different problems on some embedded or even on some IoT applications. Either your application is working on server side or the client side. So basically, all these Intel provide some pre-optimized libraries that can help you on all of these problems. So let's look at the first library, Intel IPP libraries. So basically, this is a libraries. So that is focused on the image and signal processing. So basically, we have a bunch of the domains, like image processing domains, can help us to processing some image related questions. For example, you have some print image or some medical images. So if I want a faster implementation, like do some image resize or some process and color conversions on some images. So basically, all of these libraries, you can find all of these basic functions on the image processing libraries. So besides the image processing functions, so we also have a few of the computer vision functions. And one of the typical usages is that you can use Intel IPP image with some computer open source OpenCV functions. Basically, so if you do some computer vision code, you can use IPP to accelerate your code performance. And besides the image processing part, another pretty important part so is on the signal processing part. So basically, on the signal processing part, and if you have to do some like FFT transforms, and if you have some signal, if you want to add one signal to another signal, do some filtering on these domains. So Intel IPP signal processing functions can help you to provide a very fast, optimized implementations on the CPUs. And it also have a vector math. So basically, you can do some vector computations. For example, you have one vector data you want to add into another vector data. You can use the vector math functions in this domains. Besides this one, especially on the server side, we offered many of the data compression functions, like gzip data compressions, LZ4 data compressions, and even some LZO and some bzip function and the bzip functions. Basically, it can be used for different scenarios. We'll go to a bit more details. So if you have a lot of data working on the server side, the IPP is also offering many data compression functions that can help you on this field. And the data encryption and the decryptions. So basically, so if we have some data, if I want to do some encryption, for example, if I use some AES encryption algorithms, and also we provide a very fast implementations on the encryption part. It's very simple. If you want to do some data encryption, data decryptions, based on these APIs. Also, this APIs is just a very simple APIs, and it is very easy to use and can be run on different processors. Either you are working on Atom embedded processor, or even on the server side, or even on the client core side. So basically, all of these APIs support these primitives. And we also offer a few of the string processing functions that can help you to process the strings. So all of these are some basic primitives. Let's go to another part regarding these ones. So where IPP can benefit on the IoT applications. Basically, it can benefit on different fields, either on the cloud, for example, from the IoT, some server-side application. If you have some server-side, so basically on the on the IPv side, it has some data compression functions that help you to do some data compression on the servers. And even if your applications relate to some images, and also these libraries can help you on this part. And if you want to do some data communications from server side and to your edge side, basically, and this library can help you to compression the data and communication the data and decompression the data. So this is it has a many typical usage on this ones. And if you have working on special industry, like if you're working on some medical industries, IPP providing some image functions that can help the medical image processing. If you're working on the storage side, it can use some data compressions. On the printed side, it offering some print image domains. And one of the very typical domains on the IoTG and embedded side is on the digital surveillance side. So basically, these libraries offer many computer vision libraries, image processing libraries, that can help you to handling the image and computer vision related problems. And the signal processing, just some special signal processing on the embedded applications and the machine versions and IVI applications. So basically, this is a very extensive libraries that can support different usage on the embedded side. So basically, if you have a code that relate to the signal, image, data compression, data encryption, and problems, so these libraries provide a very fast, optimized implementations. So from applications. Also, so why Intel teams working on this library? A typical reason is that we want to optimize these libraries for different processors. If we have a new processor come out, so basically we will come out new versions into IPP libraries. So for the users, you just need to relink your application to the latest of the IPP libraries. So basically, you can get a very good performance and take the advantage of the new processors. You don't need to rewrite your code to optimize very specially with some special optimization. So basically, the library itself can help you to do all of this works. So that is one of the reasons. So we want to provide an optimized library for these domains. Okay, so this is a very quick overview regarding these libraries. And here we can have a bit more in-depth introductions regarding of this library. So one of the often quite used domain in this library is working on the image processing domains. For example, I have image, I want to do some image rotations and do some resizing on the image. I want to do some filtering on the image. So basically, and this libraries is already provide some low-level primitives. So you don't need to rewrite your primitives. And also all of this primitive is also do some low-level optimizations on the CPUs. So now IPP have more than 2,000. So basically image processing APIs. So it is almost include all basic image processing functions and that can be used for different applications. It can support different data format. For example, it can submit some 8-bit images. It can it can support some 32 flow point format images. So that is a very extensive image processing libraries that can be used to support for different applications. Also, for all of these image processing libraries, it provides some low-level optimizations. So basically, a majority of these functions take advantage of the latest CPU SIMD instructions. When I talk to the SIMD, that means single instructions, multi-data, because modern CPUs are providing such kind of the SIMD instructions that can help you to improve the performance a lot on the processors. So basically, majority of the IPP functions do such kind of the low-level optimization, take advantage of such kind of the SIMD instructions, and it is a beta performance. And besides some low-level APIs, the libraries also provide C++, some high-level APIs. So basically, your application can simply call this high-level APIs. And in the recent release, it also supported some 64-bit images. So that is just used to handling some very big images. So basically, this is a very common use domain for the image processing, and all of these libraries is provided for more than nearly 20 years. So basically, it's a long history, well-optimized library for image processing. Okay, another domain for Intel IPP is just for data compression domains. So basically, all of this domain is that can both works on the some server side. If you have some IoT application on the server side, or even it can works well on the edge side. So basically, these libraries, these domains provide several common used data compression algorithms. So here I list several algorithms. We have IPP support bzip2, LZO, LZ4, and zlib data compression functions. Basically, all of these libraries can be used for different usage cases. For example, if you're looking at the bzip2, so basically, this data compression algorithm is a high ratio compression algorithm. It can achieve the very high ratios compressions. But the disadvantage for this data compression algorithm is the compression performance is low. On the other hand, the Intel IPP offered another library. It's called LZ4 libraries. For LZ4 libraries, basically that is a very relatively low compression ratio data compression algorithms. But this data compression algorithm is very fast, so it can be used for some real-time data compressions. For example, if I have applications, I want to do some data communications between the server side and the client side. So basically, I can use the LZ4 to do the data compressions before the data transmissions. Okay, and when the client side receives the data, then it can do the decompressions. LZ4 is a very fast data compression algorithms, and so basically it can be used for some real-time transmission cases. So basically for IPP side, so an IPP offered from some high compression bzip algorithm to some low compression LZ4 data compression algorithms. It supports several ways for data compressions. And another very common used data compression algorithm in IPP is zlib, because it is actually some kind of de facto compression standard. Many file archivers, many file format is just use zlib for the data compressions. So basically, that is a very good balanced data compression algorithm. So it can have a kind of very good compression ratios. Also, it can also achieve very good compression speed. So basically, that is also a very widely used compression algorithm by different applications. So from the IPP point of view, it can support different ways for data compressions. So either you can, if you want to just want some high compression algorithms, you can choose like some bzip2 or zlibs. So if you just want to some very fast, some very fast compression algorithms, so basically you can choose LZO and LZ4. And another aspect regarding all of these data compression libraries labs. So basically, all of these libraries is compatible with the open source libraries. If you have applications that is based like on the open source zlibs. So if you want to just move IPP, optimize the zlib, actually it's very simple. What you need to do is just relink your library from the open source zlib libraries and to the IPP zlib libraries. You don't need to change any APIs. You just relink your application to the IPP zlib. You can get a very good performance improvement. So that is also another advantages. So basically, this libraries is keep compatible with all the open source libraries. Okay, and another domain for the Intel IPP library, it is focused on the data encryption and data decryption domains. If you're looking at the data encryption and the decryption problems, so in these libraries, it supports some the data encryption, decryption in several problems. For example, the first problem. So if I want to encryption some data and decryption some data and store some data, so basically IPP provide semantic data algorithms like some AES and the TDAs, and even if you working on some Chinese algorithms, it supports SMS and encryption data compression algorithms. So basically, all of these are some semantic algorithms, and you can just use one key for data encryption and for data decryptions. So implementations for such kind of the encryption decryption is very fast, and also security is also very good. So basically, so this is a common algorithm used for the data encryption and the data encryptions. But there is another problem is that if I want to transfer a key, encryption keys to another parties, so how can I use this one? So, but basically, it uses some asymmetric algorithms that can be used for the key exchanges, like some ISA algorithm, DSA algorithms. So, but basically, IPP can support different algorithms on some asymmetric data encryptions. So actually, so for that algorithm, it has a public key, and it also have a private keys for data encryptions and the decryptions. And IPP is also support some authentications and some hash functions. For example, it supports some SHAM, MD5, and other few of the common used hash functions. So if you have some data, so basically IPP provide all of these functions to do some hashings. Basically, a hash algorithm is also a very popular used algorithm by different applications. So for data encryption and decryption part, so these libraries also provide some several fundamental APIs. And also this API, all of these APIs is also optimized for specific processors. For example, for AES is an encryption decryption algorithms. The modern processors and often support some AES-NI encryption instructions. So basically, IPP will take advantage of that instructions and get the beta performance improvement. So on these ones. So that is some data encryption and the decryption functions offered by these libraries. And so here I just show you some performance data that we can get from this library. So basically, why we offering such kind of libraries. So one of the major consideration is that we want to provide a very good performance, and you can take the latest instructions from the CPUs. Here we just list a few very typical image processing, image resized functions. So if you can see that we compared with the C code performance and the AVX2 code performance, and even AVX 512 code performance. AVX 512 is the latest CPU instructions provide on the server side. So basically, and these instructions can get a very good performance improvement. So if you want to take advantage of these instructions, you can just simply linking with our optimized libraries to get a very good performance. Okay, so this is just a very quick view regarding our Intel IPP performance library part. So this is just a quick summary what we offered in the Intel IPP libraries. So basically, so these libraries and we do the latest optimizations. We added a new functions on the data encryption and the data encryption part. Especially Intel IPP also do some spatial works on the data compressions, and we added a new data compression algorithm, LZ4 algorithms, and also we do continue to do the optimizations on the existing like ZLab and LZO data compression libraries. Okay, let's move to another library from the Intel part. So basically, this library is just some MQL library, Intel Math Kernel libraries. So this library is very focused on the mathematical computations. So for example, it offers some basic linear algebra functions that is very focused on some matrix computations. For example, if you have a matrix multiply by another matrix, so these libraries provide such kind of the functions. So basically, also basically like some matrix multiplications also is some fundamental computations for some machine learning code. Especially if you are working on some deep learning code, so basically many mathematical computations will be converted into some matrix computations. So from Intel MQL side, it is just to provide some low-level fundamental optimized functions on the Intel processors. And also this libraries is providing some FFT functions and some vector functions and some random number functions. So basically, here we have a very quick summary. So that is what is provided in these libraries. So as we talked before, so in the previous library, we have the IPP libraries. So for Intel IPP, it's just very focused on some image, signal, data processing. But for MQL, it's just more focused on some mathematical computations, one of the often quite common used domain is just some linear algebra functions. Basically, it offers some BLAST functions, basic linear algebra subroutines, and that is focused on the matrix computations. It has the LAPACK functions that is very focused on some solving some linear equations and solve some eigenvalue problems. And it also has a scalar pack and a sparse plus and some particle that is focused on some sparse problems. All of these domains in the IOTG part is used in many of some AI, even some deep learning code. Basically, all of this code are based on some basic linear subroutines. So besides some linear algebra functions, Intel MQL also included some FFT functions. If you have some functions do some FFT transforms and even some DCT transforms. So these domains also providing a fast implementation on these ones. And in the recent versions of Intel MQL, it also provided some neural networks. So basically, if you have working on some neural networks for some deep learnings, and MQL provided some convolution pooling and some normalizations functions that can help you to for such kind of the machine learning code. Also, Intel MQL is also integrated into many frameworks, machine learning frameworks like Cafes and like TensorFlows. So basically, if you are also using some such kinds of frameworks, you can also enable Intel MQL optimizations. Basically, you can take advantage of the latest of the CPUs. And it also, MQL has supported some random number generations and supported some statistic functions and some vector math functions. So basically, so we can see that, so this library is very focused on some mathematical computations. So how MQL do the optimizations? Actually, so almost all the functions that MQL provide also have some open source implementations. Like BLAST libraries, it has some open source Flash implementations. So, but basically, why Intel MQL do such kind of libraries? So, one of the typical reasons is that we want to provide a very good performance on Intel processors. So basically, on this side, so one of the things MQL does optimization is called vectorization. Vectorization, as just we talked, modern CPUs just providing some single instruction, multi-data instructions. Multi-data instructions. So basically, for such kind of instructions, you can just use one instructions to handling multiple data. So basically, this is a way we call vectorizations. So using such kind of the low-level instructions is one of the basic way MQL to improve the performance. So this is one thing MQL do the performance optimizations. Another thing for MQL do the optimizations is just working on some multiple optimizations. So basically, modern processors offered some multiple computational cores. So basically, MQL will try to take each of the cores and provide some parallelization code to get some better performance. And even if you have some multiple machines, even working on some cluster systems, MQL can take multiple nodes to get a better performance. So basically, you can see that MQL both can take advantage in the one course to get a good performance, and it can also try to use multi-core, and even can try to use multi-load in one clusters to get some better performance. So this is actually the way Intel MQL do the optimizations. Okay, so this is one part on the Intel MQL performance. Here we just list one function called SGMM. So basically, this function is just a basic matrix and a matrix computation function. Actually, so this function is some fundamental mathematical computational functions for many applications. So many applications actually is based on some matrix computations. So here we can see that. So even for single provision and SGEMM functions, MQL can reach about 600 gigaflops. So for when the matrix size is large enough, in many cases, MQL can reach very close to the theoretical performance of the systems. So that is a very fast implementation. So basically, it takes advantage of almost all the CPU resources. And also MQL have another functions called DGIM functions. We can see it also have a very similar performance. It can very close to the theoretical system performance on that CPUs. So basically, this is a well optimized libraries for the math computations. Okay, what we improved for this library? Actually, this library is also exists close to the 20 years. It's a long history libraries. We continue to improve its performance, adding the new functions and to support different requirements. So on the blast part, we improved some small matrix computations. We offered some optimizations on some convolutions, and we also provide a batched APIs. A batched API, that just means if I have multiple matrix and I need to do some computation, for example, for matrix computations, you can just provide multiple matrix into one function API, into one function call. So basically, that can help us to improve a lot of the performance, especially if my matrix size is very small. And on the LA pack part is also focused on the performance improvement, and it also introduced many new functions on several domains. Okay, so this is a library actually is very focused on the mathematical computations. So basically, this is a pretty new libraries that is very focused on some machine learning code and the data analytics problems. So basically, it offered some many algorithms on some classical machine learning applications. So here we just provide a list of a few of the basically functions. So one of the basic functions that provide from Intel Dell part is some data transformations and analysis in the Intel Dell libraries. So basically, all of this library is just focused on some data statistics and functions and some correlations. For example, the cosine distance and correlation distance. So basically, it provides a very basic statistic functions on this one, and it also provides some high-level matrix factorization functions like SVD and QIs. So basically, that is used for data processing and some PCA algorithms. So this is one of the part that is provided these libraries. Another library that is offered in the Dell part is just focused on the machine learning libraries. So basically, if you're looking at some machine learning code, so in this library, it provides some supervised learning algorithms and some unsupervised machine learning algorithms. If you look in the supervised algorithm, it provides some classical machine learning algorithm like some linear regressions, some decision forest and some decision trees. And so basically, it offers some very several basic classical machine learning algorithms in these libraries. It also provides some high-level, some neural network interfaces. So basically, so you can if you just want to develop some simple neural network applications, and you can also call these APIs to implement some simple neural networks. So why also it is similar. Why we're working on this library is also for the focus on the performance part. All of these libraries are well optimized for good performance. So this is one part. So we do the optimizations. So besides some supervised learning part, it also provides some unsupervised machine learning algorithm, like some k-meanings. So basically, so it can also used for some classifications. So from these libraries. Okay, so this is a quick summary. So what is offered from this library? For Intel Dell libraries, so that is very focused on some classical machine learnings and provide some very basic fundamental functions focused on some classical machine learnings. And so this is just a very quick comparison with the Spark machine ML libraries with the performance. You can find that so basically we do a lot of optimizations and to get a much better performance and on these libraries. Okay, so this is some Dell libraries that is very focused on some classical machine learnings. So in the previous libraries we just talking about, so basically, so we provide some fundamental functions. So basically, if you can direct call of these APIs, and for your applications, we have the image processing, signal processing, and some data compression, data encryption, even some mathematical computations. Basically, we provide some different kind of functionalities for different application domains. And from another point of view, we also have threading libraries. That means that if you yourself want to developing some multiple threading applications, and we also offered threading libraries can help you to resolve some threading related problems. Because if you want to do a very fast, a very efficient threading, it may have many difficult problems. For example, if I want to parallel my algorithms, if application create too much threadings, that will be create a lot of threading scheduling overhead, right? If my system have very limited code, so if I maintain too much threadings can create a lot of overhead. If I only to create a very small threading, a small number of the threadings. Basically, there could be a lot of the load balance issues. Basically, if I want to developing a very efficient threading code, that actually I need to face a lot of challenges. Also modern CPUs is developing, and it will add more and more CPU costs, right? If you want to add scalability in my applications, it is also a kind of challenge. So basically, the Intel is also offered a threading building block. So that is on the mating threading libraries can help you to resolve such kind of the threading related problems. So what is included in these libraries? So it is, first it includes some general parallel algorithms. So that means, for example, I have for loops. So basically, so you can just change your for loops into like a TBB for parallel for loop. So basically, so TBB will automatically change your for loop into a parallel for, and it can run on different processors and get the performance. So that is some general parallel algorithms. It also provides some flow graphics. So basically, you can define your application into some graph, and TBB will generate some parallel code according your graph. And it also provide some task scheduler. So basically, task scheduler, so that means for your applications, you will just very focused on some high-level tasks. And TBB will be do some scheduling, mapping your high-level tasks to some low-level threadings. So basically, internally, TBB will provide a task scheduler. So such kind of the task scheduler will mapping the high-level tasks into the low-level threadings. So it can help you to maintain the threading efficiency. So that is one of the internal things that is provided by the TBB part. And also for this library, it also provides some APIs on the memory allocations, because memory allocations essentially it is just some sequential operations. If you have many memory allocations and deallocations, it can bring some performance problems. So TBB so internally also provides some parallels to memory allocations that can help you to improve the memory allocations and the deallocation problems. And besides these ones, and this threading TBB also provides some concurrent containers and some synchronization primitives. So basically, all of this are just to help you to improve the performance on the threading the codes. So let's look at a few of the more details regarding this one. So basically, this is a very just a very simple performance data. This data is just showing the scalability of these libraries. If my library, if my applications is designed with the TBB, here we list a few very typical applications, and 5, 10, 15, and 20. Here is just the different threading number or different core numbers in my systems. You can see that basically, if my code is designed based on TBB, so the code will have a very good scalabilities. If I increase the core numbers, so basically, the performance will be improved according to the core numbers. So it can have a very good scalabilities. So that means that in the future, if I have a system have more CPU cores, that I can even get I don't need to change much of the code. I can take advantage of the more CPU cores. So a very good scalabilities, performance scalabilities on these libraries. Okay, so let's come back to the problems. So how these libraries can help us to get a very good scalabilities? So basically, as we just talked before, in the TBB, we have introduced a concept called task. So basically, if I want to write in my parallelization code with TBB, so what I need to care is only the high-level tasks. I can divide my work into many small tasks. So basically, internally, TBB has a task scheduler. So TBB task scheduler will mapping your high-level tasks into some low-level threadings. So here, so basically, so we just showing we have 3 working threadings, right? So basically, my application will create many tasks. So I don't need to care about how the task is executed on the processors. I just need to focus on very high-level tasks. So basically, TBB internal have a scheduler, so that will help me to scheduling the high-level tasks to low-level threadings. That means that if I have more CPU cores, so TBB internally can help me to scheduling my tasks to more CPU cores. So basically, so from my application itself, I don't need to care about how this task is scheduled. All of this performance performance problems on the task schedulings is handled by the TBB libraries. So that is basically a libraries offered by the TBBs. So that basically it provides tasks that can help us to easily to improve the performance on the threading code. Here we have a very typical typically so basically code on the that can be optimized with the TBB code. So basically, we have one functions that is called Mendel Computation Functions. So basically, here I have a for loop. So for these functions, so I have 2 for loops, and the inner for loop we are called Mendel functions to the mathematical computations. So this is a sequential versions implementations. So if I want to change it of this code to a TBB threadings, what I need to do? Actually, it's very simple. What you need to do, you need to change it just a for into a parallel for. Basically, parallel for is a structure that is defined by the TBB. So internally, so TBB will divide a parallel for into many tasks. And if you, for example, if I have 100 columns of matrix, so basically TBB may be divided into like 20 or 30 of those tasks. And also internally, TBB we are scheduling all of these tasks to the low-level threadings. So basically, so for my applications, what I need to do is just need to very simply change it from the parallel for to the from the sequential for to the parallel for. All of this can help me to get some parallelism, and all of my for loop is parallelized with the TBBs. It's a very simple way to do the parallelizations. Also, for such kind of parallelization, it can scale the well for different processors. If I only have two CPU cores, actually TBB can schedule my tasks into 2 CPU cores. If I have multiple, like 20 or 40 or even 64 CPU cores, actually TBB can efficiently to help me to schedule all the tasks into all of these CPU cores. That is a very simple ways we can to do the parallelizations. So basically, so this is some basic ideas of TBB to the optimization. Let me have a very quick summary. So regarding all of these libraries. So basically, so for Intel part, we're offering several libraries that can help your application to the development. So basically, it providing some IPP, image processing, signal processing, and even some FFTs and some data compression encryption functions. And we also optimize some mathematical functions that is focused on the matrix computations. And we also have some machine learning, especially on the classical machine learning functions that is provided on the Dell part. So if you want to do some threading code, so we also provide efficient threading libraries, TBBs. So that is can help us to improve our code performance. So on different Intel processors. So how you can get this package? Basically, all of these packages is a part of Intel System Studio packages. If you just download Intel System Studio, and you can get all of these packages. The latest version is Intel System Studio 2000 beta. You can just click the URL here to get this beta for testing. So so basically, and this is what we offered in the Intel System Studio. But besides these libraries, Intel System Studio also offered a few many other functions. You can visit Intel System Studio website to learn many other functions. Okay, so this is a very quick summary regarding the Intel library part. So, okay, I see a few problems on the online. So one of the questions is, how portable is the Intel MQL to non-Intel infrastructures? But basically, so Intel MQL is optimized for Intel architecture. But basically, so Intel it can also working on any Intel compatible processors. For example, if your application support like some SSE2, LVX2, your processor supports some LVX2 and your LVX optimizations. Basically, MQL also runs some optimization code on that processors. Another question is, can I port my application layer to environment running regular MQL without issue? What MQL works well on the AWS instance? Yes, Intel MQL can work on the AWSs. We do know many customers are working on the AWSs, but basically it also do some optimization code on that service. And regarding porting your applications to the MQL part, so this is depends on how you design your application. For example, so if you design, if you design the application just based on some standard BLAS interface, for example, many applications when they do the matrix computations, they just very focused on some BLAS interface. Actually, supporting your application MQL actually is quite simple. You just need to relink your applications into MQL applications. You don't need to change any of the code. So if you just base your applications on some standard like some BLAS interfaces. But if your applications use any other different APIs, for example, you just defined some your own APIs. Actually, you need to feel a bit of effort. Basically, you need to change your code into the MQL code. So I don't expect that will be some major effort for here, because many of the APIs in MQL is some fundamental or just some low-level API. So changing to this low-level API is just very simple. For example, to the matrix computations, we only have several parameters, right? So we have input matrix, output matrix, what is the matrix size. So basically, you just need to simply change all these parameters and coding with the MQLs. So basically, so this actually depends on these ones. So yeah, yes. So this is also some good questions here. Okay, thank you for joining of this webinar. So feel free to contact us, and we also have some forums. We also have some website. So feel free to contact us if you have questions. Go to our forums, or even go to our support website to ask all of these questions. Thank you. Bye-bye.